Good morning, grade 7s. I am Mr. Ntuli, who's currently teaching grade 7 mathematics. I'm so humbled, guys, to be with you today. I will be doing patterns, functions, and algebra under the subtopic of algebraic expressions and algebraic equations. All right. I'm so happy, guys, to be with you. Let us start. Today, guys, my lesson outline is as follows. First thing, we're going to touch on the mathematical vocabulary. So as we know, guys, that in each and every subject, the first thing that is most important is the vocabulary in that subject. If we understand the new words or the words that we come across or the words that are not familiar with us, then it's so advisable that we have to also make notes in our books so that we may be familiar with those words as we proceed in the topic. So the first thing that I'm going to touch on, guys, is the mathematical vocabulary, number one. And then number two, we are going to talk about algebraic expressions. I believe Mr. Ratsiu was here earlier on. He touched on, so I'm not going to just redo or take away what he has already covered, guys. He laid a good foundation for us. So I'm just going to be taking you through what he has already laid out so that to make this interesting and fun with you guys. Also, we're going to also re-emphasize on what is an algebraic expression. We're also going to explain what it means right in the terms of an expression. And then we are going to identify the variables, numeric coefficient, and a constant. Then we are going to write word problems in mathematical language. Then we are going to write phrases as expressions where the unknown is going to be replaced by a variable x. And then we are going to find the values of the expression. Quite a lot, but don't worry, guys, this is just so little. You will see when we go through. Most importantly, it is a mathematical vocabulary that we have to understand when we come across certain words. What do those words mean, and how can we be able to put in our number, how can we identify them in our number sentences, and how can we solve problems now later on when we come across number sentences. Right. Now, first thing that I've said, guys, the mathematical vocabulary. Mr. Ratzi has already alluded to this, guys. So I'm just bringing it again so that it can stick to our minds. And what does that mean? It means that when we look at this, it has got word, operation, and meaning. Then under words, these are the words we are going to come across most in our number sentences. So in our number sentences or in our problem-solving scenarios, we'll come across these words. So we must know when we come across the word sum, what it means to us, the word increase, what it means, the word more than, what it means. There are others like all together. So we have to know, okay, when I come across this word, mathematically, I'm going to add. I'm going to add mathematically. So I'm going to use addition sign. Now, if I come across the word difference, decrease, less than, I'm going to what? To subtract. So these words are going to be very crucial, guys, when we carry on. And then when I come the word product times of, then I must automatically know that, okay, now this number sentence means that I am supposed to multiply. And then when I meet the word quotient or divide, I know that I must use the sign division. So we have to just grasp these words and say, okay, whenever I come across or make notes of them at the back of our books or somewhere, so that whenever I come across those words that are mentioned there, I already know that, okay, I come across the word sum, I'm supposed to add. I come across the word, the product, I'm supposed to multiply. I come across the word quotient, I'm supposed to divide. Right. The list is more, guys. Let us check on the next. Again, when we see these symbols, equal, it means equals to. And then this symbol, it is an equal sign with this line. This means that it is not equal. Right? Sometimes we'll find the word less than. Then the symbol to use this, that meaning is this one. And then this means that less than or equals to. And then we come across this one. Normally, I encourage my learners to use their left-hand side. When we use the left-hand side, means less than, and then our right-hand side means greater than. Right. Now, we can see, all right, if I'm using this in my left-hand side already, I'm using less than. This side means less than, but this one means greater than. I mean, those of us who are right-handed, we normally know that, okay, should I raise this side? I know that the power comes this side. So it shows that it is greater than, but this one, it is less than. So for a person who is left-handed, this would mean that this is less than, although it may not confuse, but we should know that, okay, when I raise this side, it is less than. Right. And then this means squared. The one that has been raised to the power of 2, it is squared. And then this side, it means square root, not squared, square root. So the squared and the square root are not going to be the same in numbers. And then this one that has been raised to the power of 3, it means cubed. And then the sign here, this sign means cube root. Right. Now, guys, let us move on. Now, let us touch on the main thing that we have to touch on today, which is algebraic expression. After doing that small revision on the word problems, on the mathematic vocabulary, now let us get to the big elephant in the house. So, which is going to be algebraic expressions. First, the thing, as a grade 7 learner, this is a new concept, guys. Somebody will ask, what is an algebraic expression? What is he that is going to talk about? What is that going to touch on? So when we talk about algebraic expression, let us explain it. Algebraic expression is a mathematical phrase that contains ordinary numbers, variables like x and y. It may not be limited to x and y. It may be A, B, C, D, all the alphabets, any alphabet. So they will be classified as variable. And mathematical operations like addition, subtraction, multiplication, and division. Example, 5xy plus 3y minus 6. This is a typical example of an expression. Why do we say this is a typical example of an expression? Because when we go to our definition, it says it is a mathematical phrase that contains ordinary numbers. Yes, we can see we are used to 5, it is ordinary. We are used to 3, we are used to 6. These are the numbers. And it also, says variables like x and y. We can see we've got x and y there. And mathematical operations like addition, subtraction, multiplication, and division. Yes, there is a sign there which is addition. There is a sign here which is minus or subtraction. So, yes, this qualifies it as an expression. But then in expression, we have what we call terms. Then the question would be, what are terms? Terms are parts of an expression which are formed, separated, and then put together with operators like addition or subtraction, are known as terms. So in our expression, we'll come across what we call terms. So we must know what are terms. That terms are expressions which are formed, separated, and then put together with operators like addition or subtraction. All right. Now, let us see right in terms of an expression. The question would be, we've got 3a plus 2b minus 3. Is this qualifies as an expression? Yes. Why? Remember, we said an expression is a mathematical phrase that use ordinary numbers. We've got 2 and 3. 2 and 3, these are ordinary numbers. Also, it says it has variables. We've got A and B. A and B are going to be our variables. And it also says that we use operators like addition and subtraction, multiplication and division. But in this case, we can see we've got plus and we also have minus. Right. So it qualifies as an expression. Let us check at this bullet number 2. We've got 5xy divided by 2x minus 2z. Now, is this an expression? Yes, it's a mathematical phrase that has got ordinary numbers. What are those ordinary numbers? It is 5 and 2. And then, does it have variables? Yes, variables are x and y and z. So those are the variables. So it means that these qualify as expressions. Again, guys, we must not forget, expression is a mathematical phrase that uses ordinary numbers, variables, and basic operations like addition, subtraction, multiplication, and division. So whenever we see something like this, automatically we must think, okay, whenever I see numbers having variables or having words, then we automatically talk of an expression. Right. Now let us see. We're also going to touch on now, after having done so, identified an expression, now we've got to identify the variables, the numeric coefficient, and constant. Let us take a look at the following given examples. Sorry. So here we have 5 multiplied by x multiplied by y plus 3 multiplied by y minus 6. Right. Now, let us just take a look. It is 5 multiplied by x multiplied by y plus 3 multiplied by y minus 6. Now, so question first, is this an expression? Let us check. First, it must have ordinary numbers. It has 5, it has 3, it has minus 6. So, first objective has been achieved. Second, does it contain variables? Yes. X, numeric, it means a number. Coefficient. Now, I need to explain, guys, this one and this one. Right. Constants are numbers that do not have any variable in front of them. They are constant. They do not have any variables. Let us take a look. We've got 5 multiplied by x multiplied by y plus 3 multiplied by y minus 6. Now, which numbers do not have a variable? I'm sorry, do not is the same as 5xy, meaning the sign between 5 and x and x and y are multiplication signs. Plus 3 multiplied by y, meaning that it is 3y. Why? Because the sign between the 3 and the y must be a multiplication sign like it has been shown there. Minus 6. Now, when we take a look here, 5 multiplied by x multiplied by 1 is a long way of writing this. So in mathematics, we just write it in short as 5xy. This does not take away the fact that it is 5 multiplied by x multiplied by y, but we are just shortening it, writing it in a short way so that we can be able to see what are the variables and also what are the constants. So in this case, let us take a look. We've got 5xy plus 3y minus 6. So after having written it in short like this, it makes it simple for us to be able to identify what are the variables and what are the constants. So as we have already alluded to the fact that variables are alphabets, so x, y, and y will be our variables because they may change. Variable, remember guys, a variable is something that will change time and again. So it will not stay the same. It will change. So in this case, x, y are our variables. Or x and y are our variables. Now, constant. What are the constant? Constant is a number that won't change. It stays there as is. It stays there as is. So in this case, our constant will be, but we should be very careful. This number, it is a number that does not have a variable in front of it or next to it. It is identified as a constant. Should it be the case that there was S, B, A, L, M in front of this 6, then it would not mean that it's a variable. It would mean that it is another number that we're going to talk about it. So in this case, this 6 stands alone here. It does not have a variable next to it. If it does not have a variable next to it, then it becomes a constant. But now let us be careful. This number, it has got a sign next to it. So if it has got a sign like this next to it, then it becomes, we take it together with its own sign. So it will mean that our constant is equals to minus 6. Because remember, before this 6 there was a sign which is a minus sign. So if it is a sign like this, a minus sign, then it will mean minus 6. Then let us come to the third thing that we're going to talk about, which is a numeric coefficient. What is a numeric coefficient? A numeric coefficient is a number that has been written next to a variable. Let me repeat, guys. A numeric coefficient is a number that has been written next to a variable. So when we take a look at our example there, we've got 5xy. So next to this 5, there are variables, which is x and y. Also, this 3, it has been written next to a variable, which means this next to this 3, we have y. So these numbers that have got variables next to them are known as numeric coefficient. So our numeric coefficient will be 5 and 3. So we have, again guys, we are able to see, all right, x and y, they are variables. Constants are the numbers without any variable next to them, which in this case, it is minus 6. Then numeric coefficient. A coefficient is a number that has been written next to a variable. In this case, 5xy. Why do we say it's a coefficient? Because, or why do we not say this 5 and this 3 can be identified as constants? Why? Because they are not constant, guys. Let us take an example. For example, let us say x equals to 2 and y equals to 1, for example. So whenever we see x, we're going to replace it with a given value. Let us take it as it was. Remember, we had 5 multiplied by x before we wrote it in short, multiplied by y plus 3 multiplied by y minus 6. So in this case, we are told that x equals to 2. So we would say 5 multiplied by 2 multiplied by y. It has been given to us that it is equals to 1. Y equals to 1. So multiply by 1 plus 3 multiply by y. Y equals to what? 1 minus 6. Let us sum them. Remember guys, again, BODMAS. Whenever now we are supposed to calculate, we should not forget our lovely friend here, which is BODMAS. So BODMAS tells us that before we can add or subtract, we should start by multiplying, because m comes before a. So let us see. 5 multiplied by 2 equals to 10. And then 10 multiplied by 1 equals to 10. Plus 3 multiplied by 1 equals to 3. Minus 6. Now let us take a look. Initially, when we started, we had 5. But before we can sum it up before the solution, now this 5 has been changed to what? To 10. Why? Due to the variable that was next to it, which was x and y. So it cannot be identified as a constant. Again, what about this negative 6? Is it still negative 6? Yes, it is still minus 6. So if it is still minus 6, it means it was constant, because all the way it was not affected by the variables or the values of the variables. So it means this number is a constant. So we should always differentiate a variable from a numeric coefficient and a constant. A constant stays as is. It does not have a variable next to it. It may be 6, it may be minus 6, like in this case. And then variables will always be the alphabets, A up to Z. It could be any variable. It could be any alphabet, guys. Could be A, could be B, could be C, could be D. Could be any. So whenever we see alphabets written together with numbers, already first we see that it meets the definition of a algebraic expression. It is an expression because it has got what? It has got mathematical phrases. It has got variables. It has got ordinary numbers. It has got basic operations like addition, multiplication, and subtraction, and together with a division. So this was just an example to show that a variable is an alphabet, a constant, the difference between a constant and a numeric coefficient. How do they differ? So this one is affected by the variables next to it. So is a number next to a variable is known as a numeric coefficient. Right. Now, again, in this case, let us take a look at this one, which is bullet number 2 here. We are given 3b plus a minus 2z plus 5. Now, it is 3b plus a minus 2z plus 5. Now, let us take a look, guys. Remember, in expanded form, let me use the word expanded form. In expanded form, guys, this is the same as 3 multiplied by b plus a minus 2 multiplied by z plus 5. Now, let us see. In short, it is going to be 3b, because we know that the sign between 3 and b is going to be a multiplication sign, plus a minus 2z plus 5. Now let us identify identify number 1, variables. Number 2, constants. Number 3, numeric coefficient. Right. So let us take the one that has been written in short so that it can make it simple for us. Right. What are variables here? So let us take a look. It is 3b plus a minus 2z plus 5. Remember, we said a variable is any alphabet. Now, what could be the variables here? What are the alphabets there? Alphabets is going to be A, B, and Z. So these are going to be our variables. What is a constant, or what are constants that could be found here? A constant is a number that is standing on its own. So it's going to be plus 5. Our constant is plus 5. What about a coefficient? Remember, guys, we said a coefficient or a numeric coefficient is a number next to a variable. A number next to a variable. Let us check the numbers next to their variables. First, we've got 2, and then second, we've got 3, which means our coefficient is 2 and, I'm sorry, guys, it is 3 and 2, or 2 and 3, because they are both written in front of the variable. Again, this a here, you would see later on when we do in grade 8, guys. I'm very sorry to have to touch on this. This a here, it has got a coefficient. In most cases, it is invisible, but automatically or advertently so, we must know that it has got a variable next to it. I'm sorry, it has got a coefficient next to it. It has got a coefficient which is 1. So if it has got a variable that is written on its own there, automatically we must know that we've got a coefficient which is 1. But we're going to touch on more on this when we get to the next grade, guys. But at the moment, we'll just have to deal with these ones. So whenever you come across a variable, a numeric coefficient that is invisible, you must remember this class, guys, that we did just to introduce it a bit, that if a variable has been written standing alone like that, automatically there is one there that is invisible, but we'll touch on that later on. So let us get to back to the current lesson, guys. First we said, okay, we were given 3b plus a minus 2z plus 5. Then we needed to identify variables, constants, and numeric coefficient. Now, variables, we said they are all alphabets. According to the information here, we've got B, A, and Z. All these ones are the variables. And then we said we've got a constant of plus 5. There it is. And we said we've got a numeric coefficient. Numeric coefficient is a number before a variable. We said it's 3 and 2. But we said, remember, this is a variable. There is a number next to it, even if it is not there. Later on, we'll touch on it that it is 1. But for now, we'll just stick to this one. Right. All right. Now, let us check at the last bullet. Here we are given 6m plus 2d plus 7. So we are given 6m plus 2d plus 7. Remember, this is the same as 6 multiplied by m plus 2 multiplied by d plus 7. So in short, this is how it's written in mathematics. So we just write it as 6m plus 2d plus 7. Not forget that the sign between 6 and m is a multiplication sign, plus the sign between 2 and d is a multiplication sign. So we are interested to it as being it like this. Right. So let us begin. Let us also identify. So our task again is to identify, number 1, variable or variables in this expression. Number 2, constant or constants in this expression. Number 3, numeric coefficient. Numeric coefficient. Right. We've got 6m plus 2d plus 7. What are the variables? All the alphabets in the expression. In this case, we have m and d. So our variables will be m and d. These are our variables. Constant. Remember, we said it's a number that is standing on its own, does not have a variable next to it. So in this case, our constant will be what? Plus 7. And then our numeric coefficient, remember a numeric coefficient is a number next to a variable. In this case, the numbers next to the variable is 2 and 6. So our numeric coefficient is going to be 2 and 6. Right? Right. Right, guys. So from here, we could be able to see that we can identify a variable, we can identify a constant, we can be able to identify a numeric coefficient using these examples. So guys, I would encourage you guys to do more from our textbooks. We can go through all the expressions, identify which ones are variables, identify which ones are constants, and identify which ones are numeric coefficients. Bearing in our mind that a constant stands on its own, it does not have a variable next to it. A variable are the alphabets, and then a numeric coefficient is a number next to a variable. So if we have them, then it's going to be simpler for us. The more we practice it, the simpler it will get for us, guys. So please, let us just go through them, do them as often as possible. Now let us move on to the next one. Now again, here, we are going to touch on writing word problems in mathematical language. But when we touch on this one, guys, the most important part is that we have to bear in mind that mathematical vocabulary is going to come at play here. That mathematical vocabulary that we touched on earlier on, please guys, here it is going to play a very key role. For example, let us find the mathematical word problem is given to you as the difference between 69 and 43. Key word there, I've highlighted it, the difference. Now remember guys, we've got addition, subtraction, multiplication, and division, which are 4 basic operations. But in this case, the question would be, where in which one do I see the word different, or do I use the word difference? Is it in addition? Is it in subtraction? Or is it in multiplication? Or division in this case? So if we have not yet grasped the mathematical vocabulary, this is going to be something difficult for us to be able to identify or to work it out. But if we know it, we already know, or we practiced it and we mastered those mathematical vocabularies, then we definitely would understand that the difference means that I must what? I must minus. So the word difference, find the difference. If it says the difference or find the difference here, it would be associated by the sign minus. This means that what must I do? I'm going to what? To subtract. So it is the difference between 69 and 43. The difference. So we said the word difference. What does it mean? It means that I'm going to subtract. I'm supposed to subtract. So the word difference says, what must I do? I must subtract. Which number from which number? I must subtract from 43. I'm supposed to subtract 43 from 69. So when I write it in a mathematical way, I would say it is 69 minus 43. Remember, we are not interested in the solution here. We just want you to write it in a mathematical language. Right. So the difference, we have now grasped that the word difference, it means I must subtract. Now, let us look at the second one. The second one says find the sum. The word that has been highlighted there is the sum. So the sum of 112 and 28. The sum of 112 and 28. Key word there is what? Sum. So you guys, when you are given a word problem, it is advisable with a pencil, guys, just highlight which word is going to make things easier for you, or which word will cross your mind and think and say, okay, this is the operation that I'm supposed to be using. So in this case, if it says find the sum, it means that I'm supposed to what? Going back to mathematical vocabulary, guys, crucially so, it says the sum means that you're supposed to what? The sum. Meaning everything is coming together now, the sum. So when we find the word the sum, then we know that I'm supposed to what? To add. So the sum is associated with the word, with the sign addition. So which means this is going to be equals to, or we're going to write 112 plus 28. Because we see the word sum. The word sum means that I'm supposed to what? Supposed to add. So can you see there, guys? Very good. When you understand the vocabulary, everything becomes simpler. So we can be able to solve problems. We can be able to write our number sentences or even analyze and simplify them. Because why? We need to understand the mathematical vocabulary and know whenever we read, highlight or underline with a pencil that, okay, here I'm supposed to add, here I'm supposed to subtract, here I'm supposed to multiply. So nice. Right. Guys, let us check. The third one, it says 1/3 1/3 of 24 increased, the word increased by 8. So we have to write it in a mathematical way. So it has been given to us as a word problem or as a number sentence. So in fact, it has been given to us as a word problem, not as a number sentence. It has been given to us as a word problem. So we have to write it as a number sentence or as in mathematical language, what we normally understand. Now let us start. We have a 1/3 here. We've got a lot of challenges here. We've got 1/3. But then there's a word that has been highlighted there, increased. So can you see, guys, whenever I read something, I highlight the word that may be of use to me so that I can be able to solve this. So the word increased, it says something to me. It reminds me of something in the mathematical vocabulary. So when I go back to my mathematical vocabulary, let us quickly go back there, guys. Mathematical vocabulary, let us quickly go back there and see. So in our mathematical word problem, we see the word increase. And which operation must be used there? Addition. Addition. So when you see the word increased, now you must know that it has been increased. It means that I must use what? Addition. But in this case, not only increased, we've got another word there, of. 1/3 of. So the word of, it shows that when we go back to our mathematical vocabulary, we are supposed to what? To multiply. So we have to write it in a mathematical language. Let us go through it. One-third of 24 increased by 8. 1/3. 1/3 of 24 increased, it is going to be plus 8. Therefore, 1/3 multiply, because we said when we see the word of, it's going to be a multiplication sign, by 24 plus 8. Now we have written it in a mathematical way. So it becomes easier for us to solve it. Now let us see. The last one, it says, the square root of 16 is equal to the square of 12. Again, what is the most important part there, guys, is the word mathematical vocabulary, which is going to help us to simplify or write this in a mathematical language. So it says, the square root of 16 is equal to the square of 2. The square, let us write it there. The square root of 16 is equal to the square of 2. The square root of 16 is equal to the square of 2. Careful there, guys. First, we have the square root. Secondly, we have the square. So they are not the same. And then we've got the word equal. So when we go back to our mathematical vocab, it means that we have got to be able to write it now. The square root of 16, square root of 16 is equal to the square of 2. 2 square, a square of 2, 2 squared. So this is how we then write it in a mathematical way. So a square root is this one. A square is this one. That's been raised to the power of 2. So they gave us the square of what? Of 2. Which is correct because a square root of 16 equals to 4. And 2 squared is 2 multiplied by itself. So equals to 4 as well. So my left-hand side is equal to my right-hand side, which is everything is correct. So it means I've written my number sentence correct. Or my word problem, I've written it in a mathematical language correct. All right, guys. So now, after having done that, let us then carry on to the next item. Right. Here, the heading says we are going to now write phrases as expressions. Now we're going to replace the unknown with a variable x. Now let us take a look. Previously, we were writing the word problems in a mathematical language or as number sentences. So we were successfully able to do that. Why? Because remember, guys, we said the most important part there was for us to understand understand the mathematical vocabulary. Vocabulary was very key for us there. Now, in this one, now we are going to create expressions. We are going to read from the phrases there and create the expressions of our own. What is an expression again, guys? Remember, we said an expression is a mathematical phrase that includes variables such as x and y and ordinary numbers. So when we read there, we will be seeing the numbers. Also, we'll create our own variables. In fact, in this case, we are guided that our variables must be noted or shown with the variable using the alphabet x or variable x. So our variable will always be x in this case. So we are going to create our own variables. It's going to be fun, guys. Now let us see. Let us start. The first one here, again, the product of 6 and a number is increased by 10. The product of 6 and a number. Now, when we see that, guys, again, the most important part was that we touched on the mathematical vocabulary. So since we understand the mathematical vocabulary, everything becomes easier for us to do this one. Right. So the question says the product of 6 and a number the product of 6 and a number is increased by 10. Now, the product of 6, the word product, we've got to underline it because it's going to help us somewhere. And the word increased. And the number here, those three things are very important for us, guys. Let us see. The product of 6, meaning which sign was used there. Product means that what was used? Multiplication. Of what? Of 6 and a number. Now, we are given 6. 6, it was 6. We know the product, multiply. a number. Do we know a number? It could be any number. Now, if it could be any number, it means it is variable. It could be 6, could be 7, could be 9. So in this case, we don't know what number is that. Now, if we encounter an unknown like this, being a number, now we have to be very careful. If we encounter a number like this, which is an unknown, we don't know what number is that, it means that we do not know. And if we do not know, remember the instruction says, write an unknown as a variable x. So we're going to multiply it by what? By x. So the product here, we have written that we are going to what? To multiply. The product of what? Of 6 and a number. The product is multiplication of 6 and a number. A number that we don't know, it is an unknown. An unknown is going to be written as with a variable x. Again, let us move on. Is increased does not end there. It says is increased. Now, if it says is increased, again, there is a sign, a mathematical sign there. Remember, guys, in our mathematical vocabulary, we said the word increased. It means that we were adding. So it is increased by what? By 10. So this is our expression. 6, the product multiplied by x plus 10. Why? Because where did we get 6? It was given to us. Where did we get multiply? Because it says a product. Where did we get x? A number. It is an unknown. An unknown is a variable, which is x. Increased is a plus. And then 10, there we have it. Right. Now, guys, remember, we said in maths, this one, where everything has been written as in a multiplication sign, we can write it in short. So in short, it means that this would be 6x plus 10. 6x, we know automatically that the sign between 6 and x is multiplication sign. So in expanded form, this is it. In a short form, or the way in which we are going to experience it a lot, this is it. So it's going to be 6x plus 10. Hope we get it, guys. Very nice. Right, let us check the next one. The next one says a number is decreased by the square of 4. A number is decreased by a square of 4. Let us analyze our everything then. A number. Which number is that? Again, class, we do not know which number is that. Now, if we do not know which number is that, what does that mean? It means it is an unknown. We don't know it. So this one, a number, it is unknown. We don't know it. Is decreased. When they say it is decreased, what does it mean when they say it is decreased? Decrease means going down. Going down means less. Less means minus. Thank you, guys. By a square of 4. A number is decreased by a square of 4. Now let us write it as an expression. An unknown is going to be what? X. Remember we said an unknown could be variable x. We don't know it. Is decreased minus. By what? By a square of 4. A square of 4. 4 squared. When they say a square of 4 is 4 squared. Can we see, guys? Right. So an unknown, a number. When we see the word number, automatically we know we are talking about what? An unknown. An unknown here is going to be a variable x, because as per the instruction says, we should use x as an unknown number. Right. Right. Again here, 2, the third one, 2 less than the product of a number and 8. 2 less than the product of a number and 8. 2 less than the product of a number and 8. 2 less than the product of a number and 8. We are given 2, we are given less than, we are given the product, we are given a number, and we are given what? 8. Can you see I highlight things that I'm going to use, guys, to make my work simpler? So when we highlight our things that we're going to use, we automatically make our work to become easier for us. Now, 2 is a number. Less than. So let us start. So it's going to be 2. The word less than means that minus the product of a number. A number is what? A variable. And 8. 2 less than the product of a number. So guys, when it is like this, guys, remember, when we think mathematically and in a BODMAS way, we know that we're going to start when we solve it. Should we be given how much that number is, we are going to use BODMAS. And when we use BODMAS, we're going to start by what? By multiplying. So our advice, guys, that normally the first thing that you're going to do, if you're going to multiply, you can write it inside the bracket, because you know that should you be given what number is that when you calculate, then the first thing that you're going to do, you are going to multiply. So this bracket in this case shows that this is my first operation that I'm going to start with. So 2 less than the product of a number and 8, the product of a number, the product of a number and 8. Can you see? So this is our expression. Nice. Right. Now, let us see, guys, moving on. Now, after completing these 3, it is evident that now we are able to write the product of a number and 6 that has been increased by 10 as an expression. We did it. A number is decreased by the square of 4. We did it. A number, the 2 less than the product of a number and 8, we did it. Again, guys, just to tell you something, please, vocabulary, vocabulary, vocabulary. Let us put it at the back of our minds. Always let us put it here. If we understand our vocabulary, we would be simpler. And again, guys, tip here is that always when you read a number sentence or a phrase that has been given to you or a problem, or a word problem, highlight things that are giving you ideas on how you're going to work it out. Adding, subtracting, multiplying, division, all these things, square root, they are going to help us when we understand them, because whenever we read something with somehow new or know or see that, okay, this word is going to help me to add this word, because teachers will ask, even myself will ask you guys, how did you arrive to the answer? Then you will say, sir, because I saw this word, I knew automatically that I'm going to do this and this and this. So it becomes much, much interesting and simpler. So it is always going to, you always must be able to explain after having written your expression or after having solved any problem, that what did you use? What was the key? What gave you an idea that you must use this and that? So that at least, so that you can see, all right, when you get it wrong, you will see exactly where did you go wrong and what must be changed so that you can improve and what must be done to do it right. Right. So guys, last but not least, let us focus on this one. Now we are going to find the values of the expressions. We are going to find the values now. The expressions will be given to us. We'll no longer be writing our expressions. We'll no longer be going to identify variables because we've already done that. Now what we need to do is to find the values of the expression. For example, in this case, you are given, if A is a variable equals to 2, B equals to 6, and C equals to 5, then find the values of the expressions below. 3b minus a. 3b minus a. Let us start. So we need to find the value of this expression. 3b minus a. 3b, guys, remember, the sign between 3 and b. What is the sign there? It is a multiplication sign. Right. It is a multiplication sign. Now, let us go back. We are told that A equals to 2, B equals to 6, and C equals to 5. Now, 3b minus a. So this is the same as 3 multiplied by b minus a. Why? Because the sign between 3 and b is a multiplication sign. We have already touched on that, guys. So let us find the value of this expression. So this is the same as 3 multiplied by. Now you are going to substitute b with the given value there, because you are told that b equals to 6. So you're going to say 3 multiplied by the value of b equals to what? 6. Minus. Again, you are going to substitute a with a given value there. The value of a equals to what? 5. Now we are going to say 3 multiplied by 6. Remember, Bodmas, we cannot say 6 minus 5 first because Bodmas says we should multiply before we can subtract. Now, going to start with the 2. 3 multiplied by 6 equals to what? 18. Minus 5. Now 18 minus 5. 18 minus 5 equals to what? 13. Voila. Now we have found the value of this one. Why? Because we were given an expression. This was number A. The expression was 3b minus a, and the value of b was given to us there as 6, and the value. Sorry guys, let us check. The value of b was given to us as 6. The value of a was given us as 2, not 5. So here it would not be 5 because it is not c. C is the one that is equals to 5. So in this case, our answer is going to be wrong. Can you see the importance of going back to your question again and analyzing it, whether you have done it right? Because you are able now to identify where the mistake you might have made. Like I have made one, guys, written the value of C while the expression was not C, there was A. So it is very important, guys, to double check our work. So let us see. A was given to us as what? As 2. B was given us as 6. Yes, this one is going to be correct. 3 multiplied by 6 equals to 18. Minus what? Minus 2. So let us rewrite it this other side. So it was 3b minus a, not c. So the sign between 3 and b, we know that is 3 multiplied by b minus a. So this is the same as this one. These two are one and the same. So 3 multiplied by the value of b. Now we are substituting the value of b by the given value. which is 6, minus the value of A in this case, A here is 2. So therefore, 3 multiplied by 6, when we start, we would say it's equals to 18, Potter's rule, minus 2. So 18 minus 2 equals to 16. Right. The second one, we are given here 3 inside B minus A, bracket. Guys, again, 3, let me just do this. Let us go back on top there where we are given values there. A equals to 2, B equals to 6, and then C equals to 5. So 3 will stay as 3 when we try to solve it. B, let us substitute B with the given value. So the given value of B is 6 minus A is 2, and then close the bracket. Potter's says that we should work out the brackets first. Brackets. So it's going to be 3 outside. 6 minus 2 equals to 4. Close the bracket. Now we are given the situation like this. Now the question would be, what am I supposed to do here? Do I add? No. Remember, guys, again, in our math vocabulary, this bracket, it means that the sign that must be used is a multiplication sign. If there is no sign between these two numbers, the sign is a multiplication sign. So this is the same as 3 multiplied by 4, which equals to 12. So when you've got a number and a bracket and a number inside the bracket, the sign between here, it is a multiplication sign. So this is the same as 3 multiplied by 4. 3 multiplied by 4 equals to what? 12. So have we found the value of the expression? Yes, we have found the value of the expression. The value of expression is equals to 12. Number C. In number C, right, remember we were given that if A equals to 2, B equals to 6, and C equals to 5. Right. So here, number C here, it is A plus B minus C. This one is straightforward. A plus B minus C. Now let us substitute, guys. A with the given value. A, they say equals to 2, so it's going to be 2 plus B equals to 6 minus C, which equals to 5. Therefore, 2 plus 6 equals to 8 minus 5. Remember, we work according to both mass. 8 minus 5 equals to 3. So either way, 6 minus 5 is 1 plus 2 is equals to 3. So our answer would be the same. So now we are able to find the values of the expression where one variable or two or all the variables have been given to us as a number. So we now need to understand that, okay, how do we substitute a variable? So you just go through the expression that has been given to you, identify what has been given to you, what is not been given to you, and how to work it out. Again, don't forget that always everything links or boils down to what? To both mass. The last one, we've got 4b. I thought number C was the last, guy. 4b minus 2c. Again, 4b minus 2c. What is the sign between 4 and b? This is the same as 4 multiplied by b minus 2 multiplied by c. Don't forget that. Now, 4 multiplied by b. How much is the value of b that was given to us? They said b equals to what? To 6. So it's going to be 4 multiplied by 6 minus 2 multiplied by, how much was the value of c? They said c there equals to 5. We just substitute it by 5. Therefore, 4 multiplied by 6 equals to what? 24. Minus 2 multiplied by 5 equals to what? 10. Therefore, 24 minus 10 equals to 40. Right. Guys, thank you very much. You guys have been wonderful. So I've decided to close here with the quote from our former Ubaba Nelson Mandela here. He quoted, he said, "It always seems impossible until it's done." So guys, I will urge you and encourage you guys, please, let us go through everything that I've done with you guys. Go through them, practice them at home, revise them. You will never encounter problems. Should you do it 10 times, then believe you me, you will excel. You will be the expert in this topic. Do it again and again and again. Thank you guys. I'll see you again when we deal with equations now. Thank you.